Dark matter, does it exist? What is it? What does it do? This is a question that scientists have asked themselves time and again. And as Neil deGrasse Tyson once said, dark matter matters. In this video we will delve into some of the theories that try to explain the mysterious phenomenon. But let us first take a step back, and also if you could like, share and follow, that would be so much appreciated. So what is dark matter and why is it mysterious? Well, to answer that, we need to go back to the 1930s, when astronomers noticed that galaxies were spinning faster than expected. They realized that there must be some invisible mass holding them together, otherwise they would fly apart. This invisible mass was dubbed dark matter, and it is estimated to make up 80% of the matter in the universe. But what is it made of? That's the big question that physicists have been trying to answer for decades. Dark matter does not emit or absorb light, so we can't see it directly. But we can infer its presence by its gravitational effects on normal matter and light. For example, dark matter can bend light from distant sources, creating a phenomenon called gravitational lensing. Dark matter can also form large structures called halos around galaxies, where stars and gas orbit. By measuring the motions of stars and gas, we can estimate how much dark matter is in a galaxy and how it is distributed. One of the leading theories of dark matter is that it is composed of exotic particles that interact very weakly with normal matter, and themselves. These particles are called WIMPs, which stands for weakly interacting massive particles. Many experiments have been searching for WIMPs, but so far none have found any convincing evidence. Another theory of dark matter is that it is made of ordinary particles that are very cold and dense, such as actions or sterile neutrinos. These particles are called CDM, which stands for cold dark matter. This theory has been very successful in explaining the large-scale structure of the universe, such as how galaxies cluster together. However, this theory has some problems at smaller scales, such as how galaxies form and evolve. For example, CDM predicts that there should be many more small satellite galaxies around large galaxies than we actually observe. It also predicts that dark matter halos should have very dense cores, while some observations suggest that they are more fluffy. This brings us to the latest discovery that has shaken up the field of dark matter research. A team of astronomers using NASA's Hubble Space Telescope has found a galaxy that seems to have very little or no dark matter at all. This galaxy, named NGC 1052, DF2, or DF2 for short, is an oddball. It is very large, but very faint, with only about 1/200th the number of stars as our Milky Way. It also does not have a noticeable central region, spiral arms, or a disk. The team measured the distances to about 5,400 red giant stars in DF2 using Hubble. Red giant stars are old stars that have reached a certain brightness level, so they can be used as reliable yardsticks to measure distances to galaxies. The team found that DF2 is about 72 million light-years away from Earth. Then they measured the motions of 10 globular clusters in DF2 using another telescope in Hawaii. Globular clusters are spherical groups of stars that orbit around galaxies. By measuring how fast these clusters are moving, the team could estimate how much mass is in DF2 and how much of it is dark matter. To their surprise, they found that DF2 has very little mass and very little dark matter. In fact, they calculated that DF2 has at most 1/400th the amount of dark matter that they expected. This means that DF2 is almost entirely made of normal matter. This finding is very puzzling and contradicts the standard theory of galaxy formation. According to this theory, galaxies form inside halos of dark matter. Without dark matter, there would be no gravity to pull gas together and form stars. So how did DF2 form without dark matter? And why is it so different from other galaxies? The team does not have a definitive answer yet, but they have some possible explanations. One idea is that DF2 was once a normal galaxy with dark matter, but it lost most of its mass and dark matter due to interactions with another galaxy nearby. Another idea is that DF2 was never a normal galaxy to begin with, but it formed from gas that was stripped from another galaxy by tidal forces. However, both scenarios have some problems and require further investigation. The team is also looking for more galaxies like DF2 to see if they are common or rare in the universe. This discovery has profound implications for our understanding of dark matter and galaxy formation. It shows that there is more diversity and complexity in the universe than we thought. It also challenges our current theories and models and forces us to think of new possibilities. As Peter van Dokkum, the leader of the team and a professor at Yale University, said, "If this disparity is true, then maybe Einstein was wrong." You might think that this is a bad thing, that maybe physics is broken. But to a physicist, it is extremely exciting. It means that we can find out something new about the way the universe really is. So what's next? Well, physicists are not done yet with exploring dark matter. They are looking forward to more observations and experiments that could shed more light on this mysterious substance. They are also looking for new theories and models that could explain the observations and make new predictions. That's all for today. If you enjoyed this video, please like, share, and subscribe. And don't forget to hit the bell icon to get notified of our next videos. See you next time.